So it looks like this problem is really designed to try to test your understanding of what a limit is and when it exists and when it doesn't exist. So I'm going to start off talking a little bit about that. I pulled up another random function. This is the sign function, just to kind of look at what a limit is. So when we're looking at a limit, we usually see something like the limit as x approaches 0, and sometimes there will be a plus or a minus indicating whether we're coming from the negative side or the positive side. So let's just kind of look at this sign graph, and let's say we want to look at sign as x. So this is x, we have the x-axis, and as we're approaching 0 right here, what is sign approaching? So as x is approaching 0, the sign of x is approaching also 0. That's coming from the negative side. So what about when x is approaching 0 from the positive side as we're coming like this? Once again, the sign function is also approaching 0. Okay, so let's look at something a little bit less trivial. What about when we're approaching pi over 2? So as x is approaching pi over 2, which is somewhere in this vicinity, right here, the sign function itself, we'll choose another color, is going up, 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 and it's approaching 1 right here. That's coming from the negative direction. Same thing coming from the positive direction. Coming like this, it's approaching 1. So the key thing in this example is that everything matches. Whether I'm coming from the negative direction or whether I'm coming from the positive direction, everything matches up. And so my limits exist. Now this function that you've been given over here is a fairly simple trivial function. It's just a series of constant functions, but they've just been put together. So the sign of x is defined to equal -1 anytime x is less than 0. So let's just get a line on the graph that we have here. So anytime x is less than 0, that's over here, then this function is going to equal -1. So it's like that, but not at 0. You can see I left a little spot there. So this sign of x is defined to equal 0 if x equals 0. So let's see, we'll just put a little maybe circle right here. So this is what we're going to have when it equals 0. So then let's see, once again, our last line here, the sign of x equals 1 if x is greater than 0. So for this stuff over here, where x is greater than 0, then this function is defined to equal 1. Okay, so the interesting thing here is, unlike the sign function where everything is continuous and smooth, this function jumps around. And so if I'm looking at the limit as x approaches 0, so just like here where I had my x and I was approaching 0, I'm going to do the same thing. I'm coming along, my x is approaching 0. But if I look at the function itself coming from the negative direction, we're way down here. We're going along, we're approaching -1 because it's just constant. And a constant function, it's just moving along. It's not going anywhere. It's approaching -1. So what if I want to look at the limit as x approaches 0, but I want to look at it from the positive direction, which is denoted by, let's see, if we scroll down, you can see the little minus sign and the plus sign. That indicates which direction you're coming from. So we just looked at it coming from the negative direction. What if we're coming from the positive direction? So x, we're moving along towards 0. The function, we're up here at 1. We're moving along. We're not going anywhere. We're at 1 and we're approaching 1 because it's not moving at all. It's a constant function on this interval. So coming from the negative direction, we were approaching -1. Coming from the positive direction, we're approaching +1. That means that the limit itself, the limit as x approaches 0, not from positive or negative, just the plain old limit, it doesn't actually exist because -1 doesn't equal +1. So that's the trick here. Now, another interesting thing is to look at the absolute value, because if you take the absolute value of this function, then this whole line moves up here. So we end up with a whole nother line, and it's up here, but the absolute value of 0 is still 0. And so we still have a hole right here. But the interesting thing about limits is it doesn't really matter if the function has a hole. We're interested in what it's approaching, not what it is. And if we're looking at what this function, the absolute value, is approaching, as x approaches 0, it's approaching 1 from both the negative and the positive directions. So it doesn't matter that sine of x equals 0 when x equals 0. The limit as x approaches 0 doesn't have to be 0. Now that means this isn't a continuous function, but because the limit doesn't equal sine of x. So that's one of the interesting things that this problem is also pointing out. I hope this helps. Let me know if you have any other questions.